Hey guys, welcome to today's webinar. We're going to be going through the introduction to iLogic. So just pretty much just a run through of the basic commands, what it can do, what are the possibilities, and what are the potentials that we can go forward, leading on to more of an advanced look in iLogic at a later date. But this one is just to whet your appetite a bit to start to realize what the actual potential of iLogic is. Now, the first thing that I'm going to talk about is just who are Crosstech and who we are, because we're a relatively new company and what we do. Then we'll be going through what is iLogic, what can it do, and then I'll be handing over to Francisco, who will be taking you through the demonstration. And then at the end, just a bit of a wrap up and any questions that anybody has. So to talk a little bit about Crosstech, we started up this year by myself, Ian. We are a global consulting, support and training company. So any time zone, providing English speaking, we can look after AEC markets, MFG markets, the data management, construction. So crossing over most Autodesk products, Inventor, AutoCAD, AutoCAD Electrical, AutoCAD Mechanical, Revit, Vault, Advanced Steel, a wide range of products. And that's across consulting, so it could be Vault implementation, setup, support. We've got tech support contracts, which are not limited to the country that we are in. So I am based in Australia. Frankie's based over in the UK. So we've got tech support that could possibly cover numerous different time zones. So tech support, consulting, and any sort of support and training as well. We can work across most time zones. I say we are MFG, AEC, and data management specialists. We've been doing this for over 20 years. Myself, I've been in a number of different resellers around the world, in Australia and in the UK. I've also been in the trade, in the field, in the UK and in Australia as well. So we've got a broad range of specialities and skill sets across Crosstech. So again, regardless of where you are, we should be able to help you out with what you need. So going into what is iLogic. So if you've ever used a desktop application such as Excel, you'll probably have a good understanding about what automation is. So Excel uses a familiar thing called macros. You've probably used it in Excel before. And if you are AutoCAD familiar, you've probably used macros and list routines inside of AutoCAD as well. These are tools developed and designed inside of the product to accomplish a specific task. So the Inventor automation, it's very much the same in the sense that while the automation can take the form of many different things, in essence, it's a tool or a series of tools to automate or accomplish a specific task, process, or function. So iLogic is one form of Inventor's automation. So it's a tool or functionality of Inventor that allows you to create logic in the form of VB.NET to accomplish these tasks. So the rules are developed and organized using snippets or other code writing statements to run at given times. These are known as triggers inside of Inventor to consistently do some of the work that your engineers or designers need to do. So what can iLogic do? Okay, so you can search and change part assembly configurations automatically based on conditional statements defined in the rules. You can activate or deactivate parts, assemblies, features, components, constraints from these rules using conditional arguments. You can read, write, and react to material or appearance aspects of a design document. You can work with mass or volume of the parts and different design parameters, including updating the bill of material information when a model changes, which results in a new configuration. You can develop a series of iLogic rules to do these things, such as the iProperties, based upon different model criteria or replacing components in an assembly based on a selection made in an iLogic form, for example. or even update text blocks within an associated drawing. Now, the list that you can do things with iLogic is so long. There's just numerous different things you can do with iLogic. The question is what do you want iLogic to do for you? It can work within the drawing mode, within part mode, within assembly mode. You can have the rules running on open save, change of component. You can have the triggers running at different points. You can even have the rules to be global, which affect a wide range of different parts and assemblies across sort of numerous different projects. So that's my brief introduction of what iLogic is, what it can do. The best thing for me to do now would be hand over to Francisco. He's going to take you through, a live demonstration of iLogic. So, Frankie, if you want to share your screen.
Hello, can you hear me?
Yep.
Hello, my name's Francisco. Nice to meet you all. Good morning, everyone. It's actually midnight here in the UK, so very, very exciting, but technically it's still the morning. Ian has asked me to come along and give a demonstration on some of the capabilities of iLogic. I'm going to start off with a little bit of a demo that will talk about parametrics and how you can use a little bit of code, very simple code, to manipulate designs and hopefully make your work a lot quicker, a lot more effective. So the first will just be a little bit of a demo, and then I'll go through a bunch of examples of previously coded iLogic models. So let's get started. I'm just going to make a parametric table. So we want to make a table that we can configure. We can edit its width, its depth, its height, and maybe some features about the table. But we also want to be able to control things like material properties and maybe copy those parameters into bits of the metadata so that we can export the I properties to things like bills of material. But I talk too much. Let's get started. What I'm going to do is start off with a 2D sketch. And I'll start off as we do with regular 3D models with a 2D sketch. Make a rectangle. And usually around the time of making a model, what we do is we come along and we'd add in here dimensions, I suppose. Say that the table was 800 wide, we would add in 800. But if you've ever dealt with Inventor, you might have noticed that the dimensions all have names. So this one's called D0. If we were to add a depth here of 400, that one's called D1. This is called parametric modeling, and I think it's the root of design automation. So we'll have a quick look at what that looks like. Rather than just giving them dead dimensions, what I'm going to do is create a few parameters and let those parameters drive our model. So our first one might be width. The second one might be depth. The third one might be height. And maybe table thickness. We'll add in some more later, but we'll get started with these. Let's make our table maybe 900 wide and 500 deep. And maybe, I don't know how tall the table is. Let's say 450 tall. With the tabletop thickness, let's give it some meat. Let's make it 40 now. Looking good so far, looking good. So rather than giving it these dead dimensions, I can give it those parameters that we just specified. So here I'll say these parameters, and we'll say width. Oh yeah, looking good. And we can say this parameters, depth. Oh, looking also good. Let's go ahead and finish that sketch. And now we can extrude it. And the same is true in sketches as it is in features. So rather than just giving it a dead value for the height to specify the table thickness, I'm going to dredge up that parameter that we created. So list parameters, table thickness. Beautiful. Excellent. Wonderful. All right, so this table is pretty good, except that it doesn't have legs. So let's go ahead and add in some legs. But how tall are the legs? No idea yet. So let's go ahead and we're going to add in a new parameter, and it's going to be called leg length. However, we've specified the height and the table thickness, so the leg length is something that would be automatically calculated from that. So using some magic, we can go ahead and we can replace this dead value rather than with another dead value, but we can replace it with an equation. So we might say height minus table thickness. Oh, yes, very good. So we can see that the leg length is calculated to be 410, which is the total height minus the table thickness. Oh, beautiful looking get. Okay, so what happens when we change the dimensions? I guess let's give it a try. So here we could go ahead and we could change the width to say maybe 400, and we can see that the design changes automatically. But this is just the beginning, so hold on to yourself. We're going to use that leg length now to specify the length of the legs. So we'll come along here, and I'm going to quickly add in 4 legs. And being the lazy guy I am, I'm going to use clever parametric constraints to make sure that they're all the same size. Good stuff. And here we might say, 42 is maybe 60. Let's make that okay. Excellent. So this is where that parameter that we created earlier, the one that's calculated the leg length, comes in useful. We've got our 4 legs, and here we can specify leg length. Beautiful. Now, it might be worth maybe making them as a separate solid in case we want to separate them as different parts later down the track. Okay, so looking good so far. Now, let's see. Okay, very good. All right, so what we're going to do next is we're going to create a form. Now, a form is, well, it's very pretty, but really it's just a clever way of presenting the configurations possible to the user. For this example, the form is going to be trivial just to show off some of the things, but in reality, and you'll see in some of the later examples, it can really be used to limit what the user is able to configure about a particular design. So here we've got the table, and let's go ahead and come to the iLogic tab. Here we've got rules, forms, global forms, external rules. These 2 are the ones we care about today. So under forms, here we can go ahead and create new form, and we might say table, and here we can drag in the parameters: width, depth, height, table thickness, and leg length, but leg length will be a read-only parameter. Excellent. So by default, it's pretty boring. We've got a little form here. We can have it pop up when the pod opens up. And it's just as it was with the parameter menu. So here we can change the width. Very good. Here we might change blah, blah, blah. But say if we wanted to limit what values were permissible, we might say, instead of giving the user free rein, we might say that they are permitted to choose values between, say, 400 and 1500 with step sizes of 100. This might have to do with the availability of the wood sizes in your workshop. So I'll do the same for the other parameter. We'll say minimum value 400, maximum value 1500 with a step size of 100. For the height, maybe we're a little bit more flexible because we've got maybe a woodworking machine in the office, and we'll say anywhere between, say, 10 and 60 millimeters with a step size of 1. Oops, that was intended for table width. It's not the height. That would be a very, very short table if we made it that short. Let's try again. We'll say 10, 61, and for the height, let's say it can go anywhere between a squatting table, so maybe 250, anywhere up to, let's say, a high standing table, so 1500, with a step size of maybe 50. And now the magic happens. Here we can use the slider, and we can configure the table according to permissible values. Now, so far that looks pretty cool. It's something impressive to show people that would ordinarily have to spend hours to redesign such a thing. But it gets really, really interesting when we start to add in code, and we're going to do that presently. So, notice how when the table thickness changes, the leg length changes accordingly. Oh, very creepy. Love automation. All right, so we're going to add in a feature. Here we'll come along and we're going to put a hole in the middle. We're going to pretend this is a table for delicious, delicious Korean hot dog. It's going to have a hole in the middle, and we're going to make it, let's say 200. in diameter. Looking good, pretty good. We're going to say extrusion, take it to the other side, and we're going to give this parameter a name. This extrusion a name. We're going to call it extrusion through work hole. Yeah. All right. So what we're going to do is we're going to add in a new kind of parameter. So far, our parameters have been numerical, but it's possible to add in different kinds of parameters. So let's go ahead and add in a new parameter. And this one is going to be called, oops, it's not going to be numeric, it's going to be a text. And it's going to be called full enable, oops, two parameters. This one's going to be a true false, so Boolean, whole enabled. And it can be true or false. We're also going to add in a text parameter called whole treatment, which is going to govern how that whole gets treated. It's going to be given multi-values, so it'll have none, chamfer, fillet. Beautiful. So we've got whole enabled, true, false, and whole treatment, chamfer, fillet, and none. Before we get to the code, I'm going to quickly add in those features. So here I'll add in the fillet. There we go. And then I'll suppress that. And then I'll add in chamfer. There we go. Oh yes, looking good. Very good. Wonderful. So we've got two different features. Wonderful. So far, so good. Let's go ahead and go to iLogic. Now, what we want to do is, to the form, we want to add the ability to not only turn the whole on and off, but we also want to be able to edit that treatment. And I might change that into a tick box because tick boxes aren't intimidating. Excellent. There we go. Whole enabled and disabled. Oh no, it doesn't do anything. Now, what gives this, these configurators their brain is the code. Now, as Ian mentioned, Inventor allows you to code in VBA.net. While coding might sound very intimidating to lots of people, I assure you it's very, very easy to pick up. If you've ever used Excel before, you know that it would be a breeze because it's essentially Excel code. So here we go, we're going to add in a new rule and we'll call it maybe configure table. Beautiful. And here we've got an environment for adding code. Now, if you're a barbarian like me, you can just type in everything, but there's lots of ability to just click and point and have code automatically written for you. So the first bit of code that I want to write is to say, if that parameter that we created earlier, whole treatment is, whole enabled is true, then bring the whole to life. If it's not true, then hide the whole. So here we go. I'm going to say, if whole enabled equals true, I will one day learn to spell equals true. Then grab this feature, so that hole in the table, and make it true. If that's not true, then make it false. A simple if then else statement. So we'll say save. Nope. Else and if. I need a copy. Save and close. So wonderful. Now when we come to our form, we can turn on and off that hole very, very easily. Next, we might come along here and come to hole treatment. Now we want to give it some intelligence to say if it's got a fillet, enable the fillet. If it's got a chamfer, enable the chamfer. If it's got none, then get rid of them. So here we'll come back to the rule and we're going to add in a second bit of code. And all it's going to say is if whole treatment is equal to fillets, then, and we want to make sure that each of these is appropriately switched on and off depending on the treatment that's selected. So say, yep, if whole treatment is equal to fillet, then turn on the fillet feature. Else, if whole treatment equals chamfer, then turn on the chamfer feature. If neither of those are true, then turn them both off. And if my freewheeling code has worked out, we should easily be able to switch between a chamfer, a fillet, and no feature at all. Oh, it's looking good. It's looking good. What else can we do? What else can we do? I'll talk a little bit more about the eye properties very shortly, but I want to highlight that it's possible also to assign materials in Inventor. This might be useful later down the track for when you're exporting it to a BOM and doing the sourcing. Now, I might want to choose between a few different kinds of wood. So I might choose between birch or cherry. So I'm going to make another parameter here, and I'm going to call it table material. And by accident, I have made it a number. I'm going to make it some text. Table material. Here, go ahead and make it multi-value. And I'm going to add in wood, birch, wood, cherry as two different options. Lovely. Now, unlike the whole treatment, it's not a feature that we can really switch on and off. When you're editing the material in Inventor, what you're in fact doing is changing the material up here, which is the part of the metadata. So how can we actually do that? Let's get back to our configure table. And what we're going to do is we're going to add in a third bit of code. And this bit of code is going to be easy. As I mentioned, you don't have to type in everything like I had. There's a lot of pointing and clicking if you want it to be. So here we've got snippets on the side. It's a little bits of code that basically you can double click and it does all the writing for you. Here I can find eye properties. And I can find all of these eye properties that pertain to the part. So say the part number, the description, the revision number, blah, 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 blah. I'm going to play around with a few of these. I'm going to go ahead and find material. And I'm going to double click it. And there it's brought in the code, iProperties.material. And I'm going to say, okay, iProperties.material needs to equal the parameter table material that we specified earlier. Now, let's see if it works. Can I change the material by editing a parameter? Maybe, baby. Wonderful, beautiful, excellent, great. Okay, so you can also tie the bits of code together. So say, for example, if we've got a particularly long table, we might specify that it has to be made out of a particular kind of wood. So we might say, okay, if it's a particular length, if it's above 1400 1.4 meters long, then it has to be made out of oak for whatever reason. Maybe we've got a special deal. So what we're going to do is we're going to add in for the table material, edit wood oak as an option, and that, refresh it. There we go, so it works. And we're going to add in a rule that says that if the table is over 1.4 meters long, automatically change the material to oak. So let's go ahead, we're going to say if the length, if the width, I should say, if the width is greater than 1400, or if the depth is greater than 1400, then, and we're going to force the material to be wood oak. And just to be doubly certain, I'm just going to make sure that that parameter updates itself. Where is it? Documents, the snippet that forces the parameters to double check themselves. There it is. And let's see if it works. Oops, I will one day learn to code. If the or yeah. Beautiful. Okay, so let's see if it works. Hold your breath. We're going to change the width. We're 800, 900, 1000, 1300, 1400, 1500, and it changed to oak. How wonderful. Excellent. Now, you might notice that when we reduce the size, it doesn't change it back because we didn't tell it to. Wonderful. Okay, so two last things that I'd like to do. I want to update the description of the part according to its width, depth, height, and the table material. So I might come along here, and I'm going to add in a rule that allows concatenation. So what that means is it's going to read the parameters and form a description of it. So here I'm going to come along to iProperties, description, and I'm going to go ahead and say here it's going to be called table, and then and user parameters width, and then I'm just going to copy the accent and times and depth and times height and height. Good, looking good, excellent. And then no, one more ampersand, comma, followed by the material. Now, let's see if it works. Here we'll change something about the table. And if we come here, we can edit the iProperties, go over to the description, and wonderful. Here we've got table 1000 by 600 by 350 for a wood oak. Beautiful. Now, I'm going to show you some more complicated examples very, very shortly. But the important thing to take away from all of this is that if you know the rules that govern your design, it's possible to create configurators. So it's possible to create ways of automating the design process. Say that your company makes a family of these tables, and there's a particular rule in there that says that when it reaches a particular length, you have to throw in another set of legs. It's possible to do that. Your boss might say, okay, well, we want to make the tables, but we also want to make them as economic as possible. So you might do the pre-calculations, and you might work out, okay, well, we need a new set of legs for every 750 millimeters, or maybe every meter and a half if it's made out of some kind of metal. If you know those rules, then you can program them into the code and have your design change automatically. So rather than having to redraw them every single time and trip over your shoelaces just making a million modifications to the same thing, you can make a single model that captures all the design possibilities and then save yourself a lot of time in the design office. All right, so wonderful. I'm going to go ahead and change one more thing is, So in the iProperties, we've got this tab custom, and here you can add in whatever custom properties that you want. Now this is super duper useful, and I'll revisit it a little bit later in another example, but it's possible to dredge up the parameters that you dealt with. So say, for example, the width of the table, the depth of the table, and inject them into these parameters here. So you might say, for example, width, and rather than manually typing in a value for width, you can have the code automatically populate that. Now, why is that really, really good? Because it shows up on bills of material. That's fantastic. If you've got a frame that changes shape and the members are getting longer or shorter or changing material, it's possible to automate all of the stuff that you'd see on the bill of materials. Really, really fantastic. Okay, so that does it for my table configurator. I'm going to put it aside for now. Might save it because I'm pretty proud of the table. It's a pretty good table. iLogic table. Wonderful. It was an individual part, but I'll show you how assemblies work a little bit later. One more thing. So here's a pre-prepared example. So what I've got here is a part, and the part itself isn't really configurable. In fact, it's kind of useless, but I gave it a really, really cool paint job. So maybe you can appreciate it. What I wanted to do was make a little bit of code, and all the code would do something simple. You click a button and it exports a PDF, or it exports a 3D PDF, or it exports a bitmap or a JPEG. This is the kind of the peripheral functions that you can program into Inventor as internal or external rules that can save yourself a lot of time. So at the moment, it's a bit pointless. I can come here and I can say, find this export as PDF button, click it, it'll go off and think about life, and export a PDF. Wonderful, but not that impressive. But where it gets really impressive is where you can start to incorporate these features. So say, for example, you've got a configurator and you've got this product and you can configure it, maybe even your client can configure it in 12 different ways. It would be nice if they could then click a button and it exports a little estimate with costing and the amount of materials it's going to be and a nice picture of it. So these are the building blocks of automation, not just in design and drawing, but also in sales. So I'm going to show you, you can also export as a bitmap and a JPEG, and it's copy and paste the same principle. There you go, you've got a bitmap of the beautiful useless design. Excellent. Okay, so all of these have been a bit trivial. A walk table, that thing. Let's go ahead and look up something real. So what we've got here are assemblies, and these are real. Let's go ahead and I'll start off by showing you this box configurator. It's not much to look at, but like I said, if you understand the rules that govern your design, it becomes a lot quicker to, it's possible to automate the design and make a design rework a lot quicker. So this is a sheet metal assembly. We've got different parts here, and they're all flat pattern. So there's no tricks, they're real components. And here we can say very difficult part, and accident and close that. So what are some of the rules that govern this box? We might say, okay, well, we want to change the orientation of those handles. Maybe we don't want them width-wise, maybe we want them depth-wise, in which case we've got some rules that allow us to reconfigure where those handles are. We might say there's no handles. This one's a cheap box, we don't want handles. But maybe we do want handles, so we'll make them width-wise. Maybe there's something living inside. So we've got some vents, and there we go. We've got some vent holes on the top and the sides. Now, consider for a moment, we have one parameter here, handles, which changes where these handles are, and another parameter here that changes whether or not these vents are on. Now, there's a potential conflict here. If we were to change these handles from width to depth-wise, won't these handles then cover up the vents? Alas, if you know the design rules, then you can code it so that the vents change size. The whole point is to preserve the design intent, to capture the real form of your design, and to understand the real rules that govern it. It's hard sometimes, to write it down, and even once you write it down, and once you understand your design, putting it into code, believe me, is very, very easy. So here it might come on with additional parts. It might come with a frame. So here we go. It's a terribly designed frame with a gauze pad on it. And that gets included in the bill of materials. If you save it first. Yeah. There we go. It can produce a bill of materials. And there's the additional frame on top. Wonderful. Now, it's possible to add in codes that can, go ahead and automatically export that bill of materials, automatically produce a packing code, so basically a collection of all the components that make up that thing. But I might get to that magic a little bit after. Let's go ahead and actually, maybe now. No, soon. Okay, go ahead, save and close that. And I'll show you another example. So when it comes to Inventor, people tend to think, this is just for manufacturing, for small components. Maybe it's just for a sheet metal box, or maybe this machined component, but it doesn't need to be. In this example, what we've got, the major frames for a glass house. So something that's a meta structure. And this is a proof of concept produced for another client. And here we can come along here and we can configure the glass house. Now, you might have a whole bunch of design rules that affect, how many posts you need to have for a given length, or how thick the glass needs to be, for a given area. Here we can find that if we manipulate the parameters, those rules get applied automatically. So we're going to make it a bit bigger. At the moment, it's 20.5 meters long, and here we can change the roof angle. Now, there we have some complexity. If you consider, okay, this is a nice bespoke glass house and it's made with joinery, you actually need the material to conform with one another, because that's how joinery works. So what we have here are each of the components, and the components are themselves iLogic enabled. So they receive the angle of the roof, and they automatically compute their new joinery geometry. And like I said, and I'll hammer it home a million times, I think it's become a bit of a slogan. If you know the rules that govern your design, it's possible to program it. So maybe the joinery takes a long time ordinarily, but if you know the rules that govern the geometry of the joinery, then suddenly automating it becomes easy. Here we've got the ability to change the height, you can change the thickness, and we've got a big, chunky glass house. Cool. And maybe this is, say, for example, like a sales brochure, or maybe something for a configurator for a client. So you can change if it's got a step, if the border step is broad or narrow, and or if it has no step at all. Wonderful. Cool. So there we go. We can change a whole bunch of rules at top, and looking good. All right. So that's just to show that it can apply to larger assemblies. Let's go ahead and have a look at some real magic. So what costs a lot of time? Yeah, okay, design does cost a lot of time. It's a real pain, and then you go through the hoops and you automate the design. But what next? What else can you do? So here I'm going to show you another proof of concept. It's a sheet metal door. And in many ways, it doesn't introduce anything that I haven't shown you already. Here we've got a parameter that changes the handedness of the door. Here we can update the model. And there we go. Do you see the holes in the door? They change position, and the lock changes orientation. We might go ahead and say, let's go ahead and change the height. We might say, let's this is a 1500 tall door, and maybe it's, I don't know, 900 wide, something crazy. We can go ahead and update the model. And it's thinking about life. There you go, and it's bugged out on me. No, oh, it seems like I've forgotten the hinges. Oh, so here we can. Oh, maybe it's an opportunity. We can see that we can change the hinge types, even though they didn't load in the right place. I am sorry. So we'll go ahead and hide my shame by making the door again. Wonderful. Almost. Hey, shame hidden. Yeah. Okay, so we can change other things about this. You know, does it have a window, for example? Might update it. It has no handle, no window. Maybe it's only got 2 hinges. Maybe there's no door seal. Update the model, and it goes ahead. It gets rid of the hinges. It gets rid of the holes in the door. It goes off, gets rid of the apertures, gets rid of the handles, keeps the lock. Maybe it doesn't keep the lock. It's been a while. And there we go. We've got a simple leaf push door, and we have to configure the heights of those hinges. So you might come along here and say that hinge type 2 is maybe 200 to the hinges closer to the bottom. Beautiful. So that in itself is pretty cool, I guess. It's got a door stopper there. That's cool. Now, wouldn't it be nice if we could save that configuration? We could, save as a pack and go, copy all of the files associated with it. But we can also throw in a bit of code. And this bit of code is going to do something special. It's going to grab all the parameters that govern the design, and it's going to save them. Here we can go ahead and say export door configuration, and we might say door set 5, example spectacular. And it saved that configuration for the door. Now say I want to load up another one, maybe from another client, maybe from another job. Come in here, load up the parameters from that door, and it's going. It's thinking about it. It's adding in one of those hygiene hand pad things so you can move the door, and it's reconfiguring, and it's got 4 hinges this time, and it's almost done. There we go. A new configuration for a door. Maybe just one more. Let's go ahead and load up door set 3, see what surprise it has for us. Okay, it's a bit wider, but this might look impressive, but all it's really doing is going through all the rules that govern this door. It just saves the parameters and it just reconfigures the door according to those rules. So that's pretty cool in itself. Now you might say, okay, now the laborious process. We've got the model, so what? We've got to make a sales document, we're going to make drawings, we're going to make DXFs, for cutting these sheet metal bits on a laser. Wouldn't it be cool if we could automate that? Well, we can absolutely automate that. So you might have noticed these two little buttons at the bottom. You've got export drawings and BOM. And I'll click that. Export drawings and BOM. That's pretty quick. And I'm going to click the second one just because it takes a little bit of time. So I'll say export DXS. And what it's doing is it's going off to each of the sheet metal parts that make up this door. And oops, there we go. And we can save it. So I'll say export spectacular. It's going off and it's saving a DXF with all of the sheet metal flat patterns in there. So then you can send it off to your laser cut guys. They can cut it out and you can get to fabricating this door as quickly as possible. So let's just see that I wasn't lying. Let's go ahead and find the exported files. So here we've got exported BOM. Beautiful. And we've got the bill of materials with each of the components. And if you are super pedantic, you could include, say, for example, width, maybe sheet metal thickness in here or sheet metal material into this bill of materials. Here we can come along and we can find exported DXFs, and hopefully it didn't die. We'll see. And here are the flat patterns of this sheet metal door. All automated, all exported. It's not nested, but that too is possible. Maybe next demo. But all of the components that are sheet metal are flat patterned and exported from this, just at the click of a button. So something that would be error prone, something that would be laborious, something prone to not being that fun compared to design, can all be automated as long as you know the rules that govern your design. Cool, that's pretty fantastic. Maybe just one more. So I wanted to show how it's possible to have the bill of materials influenced by your design. So here I'm going to come along and open up a simple design configurator. Not that one, that one's not simple at all. But maybe worth having a quick look at. Beautiful. So here's maybe a little bit more of a complex design. It's a true-to-life frame. It's got notching and all of that material. But importantly, it's got rules that govern it for structural integrity. So here we can come along. We can change the stiffener gap. Here we can change the length of the frame, the width of the frame. Maybe add in a space for a crane or fittings for a crane or not. You can add in. Oh, we didn't get to end as a steps. Eventually. Here you can add in the safe working mode for the crane. And you can suggest, click this button and it will suggest crane design parameters. So the dream was that you'd have a crane that you wanted, and you'd be able to configure your frame within reason, that you could verify that the design would meet the specifications. So, if you've got a crane that's lifting, say, 1.2 tons, like it's a little crane, then you could get away with having a little frame. But if you've got, say, a 10-ton crane, then suddenly your frame needs to be a lot beefier. So this one in the background goes through a little bit of code, does some essentially what is hand calculations, and verifies whether your design is up to your own codes. So not much to look at in terms of aesthetics, but very nice in terms of the kind of things that your frame can do, that a configurator can do. I didn't intend to show it, but a similar example is this one of it's a footing. It's the footings for a building. And what you might be interested in is what is the pressure in each of the feet. Your codes might have an allowable pressure for each of the foot, for either the material or maybe the ground. Maybe your ground has to not take too much weight per foot. Here you can specify how much mass the building is. So you might say 35,000 kilograms. Click apply, and it'll go off and it'll design the footwork. So it's just a nice fancy patterning of the design. But it will then go off and tell you the number of feet that's required in order to meet this specification of maximum foot pressure, 15 kilopascals. I think I might have been a bit too gung-ho, and I think my computer is powered by a Dorito. But it'll get there. Looks tight. Oh, a million years later. but I suppose it's better than designing the whole thing from scratch. What this demonstrates is that if you have, say, for example, engineering codes or engineering things that govern your design, if you know those engineering rules, then it's possible to program in a solution that will actually drive your design. Or completely kill your computer, one of the two. Maybe I should have made the number of units a bit smaller. But we're a bit rushed for time, so I might go ahead and load up the next one while my computer's having a hard time. And here we'll come along to the one that I wanted to show you, which is the frame parametrics. And it's opening up the second instance because today is not my day apparently. We'll just give it a moment. And chill it. Which one will win? Wonderful. Okay, so this one won. This is a simple frame that I wanted to show you earlier. Now, it might be interesting to know that it's possible to dredge up common metadata in the bill of materials. So what I'm going to do is, in this assembly, I'm going to add in a parameter, or I'm going to, say, check a parameter here, and we've got a parameter called width. Now, we might say, okay, let's go ahead and in the bill of materials, add in a parameter. Nope, there. Other one here, and here we can add in parameters that we wish to dredge up. So we might say add a custom parameter width. Now, if the parameter is exported, it will show up here. So to export a parameter, we'll come along here and we'll click here, this little button. We can either click this button or we can actually add in a little bit of code that forces an export. Either or works well. And hopefully it's already done it. There we go, with 890. Lovely. Now, if we have that parameter, well, I shouldn't call it a parameter anymore. It's a metadata, an identity. We can add it to the bill of materials. And here, if it exists in the part, it will show up in the bill of materials. I can repeat that process for each of these components. I might say export, that's called length in this one. Okay, so I might have to be a little bit more clever with it. But it shows how your parameters can turn into properties, and those properties can show up in the bill of materials. So where might it be useful? This particular flooring happens to change its width and depth. So we come along here, it's called width and depth. And I might come along here and export the width, export the depth. And here in the bill of materials, get rid of that. I might add in the width, and depth. And wonderful. We'll notice that automatically the width and the depth of that chassis plate gets pulled up into the bill of materials. So if somebody's, say, for example, doing costing up for a particular, rectangular whole section components, they can just look at the bill of materials without having to dive into drawings and designs. Just before I close this example, it's a simple configurable design. So here we might say we've got the ability to change what kind it is. Does it have a foot or a caster? In which case these holes appear, there's a stiffening plate, and then holes appear. We might have another rule that governs how many stiffeners make up this frame. So we'll decrease the depth, and that's okay. But if we decrease the width, there'll be a threshold below which the number of stiffeners will change from 3 to 2. Okay, sorry, I've overrun. I talk a little bit too much. This design is fun enough, and the automation is even better. So I get carried away. Let's see if the other one. Hey, it's finally finished. Oh, you cost my computer so much time. I'm going to close you without saving. Okay, so let's go have a look. Design automation, drawing automation. Now you might say, okay, design automation, that's the hard stuff. Drawing automation, that's easy. Other way around, the drawing is the more tricky part. And I've said it to a lot of people, and I'll say it to you now. People often ask me, which is harder, 3D modeling or 2D drawing. 2D drawing all the way. The old toughs that used to draw things by hand or do everything in AutoCAD, you have to think 20 steps ahead when you're doing your drawing. there's real depth of skill when it comes to proper craft. 3D modeling is, yeah, it's definitely challenging at times, but it's a bit more like Lego, and it's very intuitive because, you know, in a 3D world, and who doesn't love Lego? Not sponsored, by the way. That was just a shout out. So drawing design, drawing automation, where does it begin? There's a bit of drawing automation that comes intrinsically in Inventor. As of about 2019, this intrinsic drawing automation has existed. So here we've got a simple design. We've got something that, you know, parameter that maybe governs the width. Yeah, something that governs the width, something that governs the depth, something that governs the height, etc. We've got the ability to turn on a whole feature, turn off a chamfer, you know, turn on the fillet there, turn off this protrusion. Let's go ahead and turn off some of the features and turn on some of the others. We're going to go ahead and save that design. We're going to go over to the drawing and say open drawing view. Has my drawings disappeared? Oh no. Oh no. Has it disappeared? That's not good. Maybe it's a good opportunity. Maybe it's a good opportunity. All right, this is an opportunity. Let's do it. Turns out that my drawing doesn't exist. So I'm going to go ahead and make a new drawing. And it'll just show the intrinsic drawing automation that comes without even beginning to code. So let's go ahead and we're going to make a quick drawing here. I might have not updated my templates just yet. So I'm going to change something very quickly. Give me one moment. This comes with help. Prepared. Automated drawings. New drawing. Needs to be migrated. Oh, bear with me one moment, friends. Autodesk. So this is an example, actually, of the kind of problems that can show up in Autodesk and the kind of things that we can give support for. So here we'll come to users, public documents, Autodesk, Inventor 2021, templates. Ooh, that was so fast, wonderful, excellent. Let's go ahead and find the ANSI millimeter drawing template and look that up and migrate it. Beautiful, done. Let's go ahead and go back to our automated drawings. And we're going to say, let's go ahead and create a drawing view. This drawing view. That was the problem. Wrong template. Facilities, no, work, CAD management, templates, 2021 template. Open up the drawing. CAD management templates, 2021. Save it. And now we can make a drawing from this new template. So we come along here, metric. Drawing. There we go. Great drawing. Beautiful. Clients, we might say, let's go ahead and say that's Globotech. No affiliation with Globotech if it happens to be a company. Wonderful. And here we've got drawing. Lovely. And we're going to go ahead and add in some dimensions. So specifically, I'm going to add in a dimension that governs this fillet and maybe this chamfer here. Now, I want you to see what happens when I update the design. So I might say, let's go ahead and save that under the appropriate folder. Wonderful. If I were to come along here, and I'm going to get rid of this fillet. So I'll say get rid of the fillet, save the drawing, and boom, if I go back to the drawing, automatically the drawing is updated. That's pretty cool. But the real treasure is if I come back and I re-enable the fillet, that drawing remembers that that fillet is there. This is incredibly useful. So when you have configurable designs and you're turning on and off features or you're adding components, it's possible to have it automatically do it for you. So that's fantastic. That's just the intrinsic stuff. That's not even code yet. So hopefully, that I have overrun, but I will be very, very quick. I wanted to show you some of the rudimentary drawing automation features. While I load this up, it's worthwhile mentioning that if you have sufficient knowledge, it's possible to have a 3D model and to automatically produce 2D drawings to your own specifications, as long as you know the rules that govern your drawings. So look at this one. Did this one work? This one was from a while back. We've got a bunch of blocks, and say that it's got just a single block. You can come to drawings, open the drawing, and here we've got some code that can hide all orphan dimensions. So there we've got the drawing with just that block. We might have another configuration where there's 3 blocks instead of 1, in which case when we go back to that drawing, those dimensions will not only can come back, but be reattached as well. So if you've got one master drawing that captures all the configurations, you can have little bits of code in there that goes in there and neatens up the drawing and automates everything. There's a little bit more that I wanted to show you about arranging dimensions, placing dimensions automatically between named surfaces, but I think I've overrun a little bit. I hope this is just a little demo, something that you could wet your whistle with, something that you can see that automation isn't this big, intimidating thing. It's easy to do. The hard thing is knowing the rules that govern your design. If you know that, the rest is easy to do. So thank you very much for your attention. I'll pass you back to Ian. Have a great morning, thunderstorm, afternoon, whenever it is in Australia. And thank you for your time. Ian?
Thank you, Frankie. All right, guys, I hope that was helpful to you guys. Like Frankie said, just a bit of an introduction into iLogic, just to show you what some of the possibilities are. There is a lot more, so hopefully in the coming future, we'll put together a more advanced iLogic video. I just knocked that on one more slide. So if you've got any queries, do get in touch. We are hosting an iLogic training at the beginning of April, a 2-day course, to take you through from the very beginning on, how to set up a form, how to start coding in the VB, how to start doing some of the tasks that Frankie showed. So if you are interested in that course, please just jump onto the website and take a look at what's involved. Otherwise, get in touch, follow us on Facebook, follow us on LinkedIn, and we do post quite regularly on updates and training courses and our blog, new information that's coming out. So please do get in touch. If you've got any questions, please stick them in the Q&A. We'll stick around for another 5 or so minutes if anybody has any questions they want to stick in the Q&A box. Oh, we have one there in the chat. Oh, thanks, Jim.
Oh, you can hear me. Thank you, Jim.
All right. Well, if nobody's got any further questions, we'll close that off. But please do, the email and website are up on the screen. This will be uploaded to YouTube. And I will share that with you all once it's done, so you can watch again. And in the YouTube description, there'll be links to the training course and so on and so forth. So I hope this has been helpful to you guys and informational. Thank you very much, Frankie, for being up so early in the morning to do this.
No, it's my pleasure.
All right. Well, thank you guys for coming along. I will stop that just there, and I hope to hear from you guys soon. Thank you very much.
Thanks, everyone. Bye.